Greetings A-level chemists. In today's explainer video we're looking at equivalent protons and how to determine equivalent protons. So when we're looking at this molecule propane, how are we going to determine what the equivalent protons are? So there is a good little thought experiment that we can do actually. So what we're going to do is, first of all, let's number the carbons. So 1, 2, 3 for sake of argument. So this is propane. Okay. So then what we're going to do is we try and do this in your head, but when we're practicing, let's just take this hydrogen for sake of argument on carbon atom number 1. Just remember that these hydrogens are all the same. It's a CH3 group. They're all attached to the same carbon. But what we can do is prove this to ourselves, okay? So what we're going to do is let's exchange that proton there for this substituent group X. So we're going to replace with X. So if we replace it with X, this is what we're going to get. So this is going to be 1, 2, 3. So this is going to be, if it was a chloro, it'd be like 1 chloropropane or something, okay? So the prefix would be 1X propane. So if we're not sure about whether these guys are all going to be the same or not, what we can do is now let's replace that proton with this mystery group X. So let's do that. And if we replace that proton with the mystery group X, let's see what we get. So if we replace this with X, just going to put CH2CH3 to save all the writing. So we're still going to get 1X propane. So these are exactly the same molecules, because remember these bonds can rotate, right? So this is exactly the same as this. So therefore we can say that this proton and even this proton, if we exchange it, it'd still be 1X propane. So these guys are all equivalent. That's one proton environment, okay? So the best way, in my opinion, to show that this is one proton environment to the examiner is get a different colored pen if you want to. And then what we can do is say that that's proton environment A, okay? So then what we're going to do, we're going to move on to the protons attached to carbon number 2, okay? So let's, by now I'm sure you all agree that these guys are going to be the same because we've got a proton here and a proton here attached to the same carbon. They're exactly the same, okay? But the question is, are these protons attached to carbon number 2 the same as the protons attached to carbon number 1? Let's find out. What we're going to do is we're going to replace the protons on carbon number 2, and if they give us a different name, then these are different. If they give us the same name, then those are equivalent to the protons in carbon number 1. And this is quite a nice way of doing it, okay? So replace with X, and we are going to get this. So is that the same as the first example? Well, no, because when we start naming this is going to be 2X propane, which is different from 1X propane or 1 chloropropane. It's a different molecule, right? So they're isomers, so these guys are going to have different chemical environments. So these guys are not equivalent. Okay, so that means this is going to be environment B. Give whatever labels you want, but those guys are chemically different from the protons on carbon number 1, okay? And if we think about this, look, we've got a CH3, so methyl group, so we've got methyl protons, and then that carbon's bonded to this carbon in the middle, and then we've got CH2 protons. So the CH2 protons are different to CH3 protons, okay? What about this methyl group at the end? Is that methyl group the same as the methyl group on number 1, or is it different? So let's have a look. Let's show with the long version first, okay? So what we're going to do is let's exchange that proton. And if we exchange that proton, this is what we get. And remember, initially our numbering system went 1, 2, 3. However, if the X is on the right-hand side, then we're going to have to give that the smallest numbering for our UPAC nomenclature. So this also becomes 1X propane. Okay, well, this on the left is also 1X propane. So these guys are exactly the same because we get the same naming out of it. And another thing to look out for, which leads in quite nicely, is symmetry. So there is a planar symmetry in this molecule. Slap bang down the middle. So slap bang down the middle is our planar symmetry, and we can see that these guys, if we just folded it, these guys are going to be exactly the same as these guys. So how many different proton environments do we have? Well, we've got proton environment A and we've got proton environment B. So we've got 2 different proton environments. We have A and B. So in environment A, how many protons do we have? Remember, the area under the curve is proportional to the number of hydrogens present. So we have 6 protons in environment A. And we have 2 protons in environment B. Done. Cool. All right. Now we should be able to pick up a little bit more pace, okay? So now we should be able to pick up a little bit more pace. So we can start numbering 1. In fact, let's number correctly. So that's going to be 1, 2, 3, 4, because the bromine substituent gets the lowest number. Okay, fine. So then we've got a CH3 group at the end of this molecule. So that is 1 environment. So if I go next door to this carbon, carbon number 2, I have a CH there. Well, look, that CH is next to a Br. If I go next door, this CH is next to an H. So are these guys the same? Let's look at their neighbors. So this CH is next to a Br. Whereas if we go to the CH next to it, it's next to an H. So are these guys the same or different? Well, they are obviously different because this one's got a Br living with it, whereas this CH at the bottom has an H living with it. It's got different occupants if you want to think about it that way. So this is going to be environment B. And then this is going to be environment C. And then you've got to think, do we have a planar symmetry? Yes or no? So if I put a line there and I fold it, do I have a mirror plane there? And the answer is no, because right here I don't have a bromine group. So I don't have a bromine atom, so we don't have a planar symmetry. So that means that CH through the other end of the molecule is going to be distinct or different from the CH3 on the right hand side of the molecule. So these protons are in a different environment. So here we have 4 different environments, okay? So this is what low resolution NMR tells us, the number of different chemical environments we have for our protons. Okay, and the integration will tell us the number of protons in that environment as well. Okay, let's have a look at another example. All right, so when I'm looking at this, first thing I'm looking for is, do we have any symmetry? No, if I go slap bang down the middle, that is not symmetrical because I don't have a bromine atom over here, but I do on this side. So let's get rid of the, let's number 1, 2, 3, 4, 5. Okay, so that's environment A. That's environment B. These guys are environment C. These guys are environment D. And then finally, those guys are right at the end, are environment E. So we've got 5 different proton environments here. Okay. If you are stuck, what you could do is you could try our trick of replacing a proton in these 5 environments with mystery group X, and then you can see what the naming would be. So for example, if we replace that, that would be 1, 2, X bromo, whatever. Okay. Then if we replace this, that would be 2, 3. Okay, and then if we replaced this one, it would be 2, 4. So you can see that they are actually all different. And then if we replaced this one right at the end with an X, what would that give us? So that would be either 1, 2, 3, 4. Yeah, so that would be 1, 4. Okay, you can see that they'd all be different. Okay, I hope we're starting to get it. Let's have a look at a few more. Okay, so let's have a look at this molecule here. Nice. Right, we're increasing the complexity a little bit more, okay? So let's start by finding the longest carbon chain with the substituents on there as well. So we have a longest carbon chain of 4 carbons, so it's going to be but something. So this is going to be butan 2-ol because I have an OH on carbon number 2. So this is going to be butan 2-ol. Okay, so then also on carbon number 2, I have a methyl group. So the prefix here is going to be 2-methyl butan 2-ol. Okay, so that's the naming part out of the way. Now we need to look at the different chemical environments, okay? So let's get rid of that in green and let's get rid of that in green. So straight away, let's do the easy ones first, okay? Well, that OH is going to be a distinct chemical environment, okay? Because this proton here is attached to an oxygen and I don't have any other protons attached to oxygens. So it's chemically different from the others because they're all attached to carbons. So this is environment A. Let's get the easy ones out of the way. Okay, so now let's have a look. Let's focus on this CH3 group, okay? So if I replaced one of these with an X, so this would become, let's see how the naming would change. Okay, so it'd still be 1X 2-methyl something, butan 2-ol, right? So using that, we'll leave that one up actually. So let's have a look at these CH3s. Let's have a look at these CH3s. So if we replaced one of these with an X, so then let's think about what my longest carbon chain is. It's still going to be 4, and then this is going to be 1X 2-methyl butan 2-ol because we're now numbering from 1, 2, and then on carbon number 2 we'd have the same methyl group substituent. So what can we say if we get the same naming? After replacing a proton with an X, we're still going to say that these guys are equivalent because they're the same molecule if we get the same name, right? So these methyl groups are exactly the same. They are equivalent. So if we label this as environment B, these also have to be labeled as environment B. They are exactly the same. And if we think about it, why they're exactly the same, we've got a CH3 attached to this carbon and another CH3 attached to the same carbon. So CH3s attached to the same carbon, for A-level purposes, are going to be identical. Okay, and then this OH is going to be different. And then this CH2, we don't have another CH2 group, so that's going to be different. So that's going to be environment C, and then this is going to be, that CH3 is different because this CH3 isn't attached to a carbon with an OH. This CH3 is attached to a carbon with 2 protons attached, so it's different to these guys. So that is environment D. Okay, let's go. Question number 9. So let's practice a little bit. Here we have to draw the structure and determine the number of 1H signals. All right, let's go. Okay, so let's start by drawing propene. So 3 carbons in a row. Got an H, 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 and CH3. Okay, cool. Let's go. So these guys are chemically the same because we've got a proton attached to this carbon of the CC double bond. This hydrogen is attached to this carbon, same carbon of the CC double bond. They're equivalent for A-level purposes. Okay, so that is environment A. This proton, however, is attached to a carbon of the CC double bond, which is then attached to a CH3. So this proton is different to these guys. Okay, so that is environment B. And these CH3 protons are different to all the others. So that's environment C. So we're going to see 3 signals. Okay, what about 2-bromopropane? All right, cool. So 1, 2, 3 carbons in a row. Bromine on that carbon. Okay. Straight away I'm seeing a plane of symmetry. So think about the molecule, eyeball the molecule, think about that plane of symmetry in molecules. So then I'm saying that these methyl protons, A, are equivalent to these methyl protons, B, due to that plane of symmetry. So if that's B, that's effectively A because they're the same. So I should have labeled it as A. And then this is environment B. So we're going to see 2 signals here. Okay, and then finally methyl propene. Okay, so then start by drawing propene, which is that. And then the methyl group can only go on carbon number 2. If it goes on 1 or 3, then it's a different molecule. Not propene anymore. So this is methyl propene. That's H and that's H. Okay, cool. Nice question. So, do we have a plane of symmetry anywhere? Yeah, we do. You can think about it like this. So, these guys are exactly the same. So let's give them the same label as A. And then these guys are also exactly the same. And we're going to give these the label of B. So we have 2 distinct chemical environments. Okay, thank you for watching. I hope that was helpful. Laters.